In part 2 of solving equations, we're going to be looking at how to solve real life or word problems. We're going to go through first the steps for solving word problems. If you look at the guiding question, it asks what these steps are, and that's the first thing we're going to look at, the steps for solving word problems. If we look, step 1 is always to define the variable, which means what is being asked. What is it that the question's asking you? Number 2 is to write an equation using the variable. Let's go back up and put define the variable and make sure we identify and understand that that means what are you looking for? And then we'll write the equation using that variable. And then the third step is to solve the equation by isolating the variable. Fourth, I will state my answer. Sometimes that answer will be exactly what you solved for. Sometimes you'll have to take what the variable that you solved for and do something else with it to come up with the final answer. And then lastly, you check answer to see if it makes sense. So the answer that you get, does it make sense for what the problem asked? We're now going to look at a couple of examples. Our first example, we're going to use a one-step equation as our model. The question says toucans and blue and yellow macaws are both tropical birds. The length of an average toucan, that's the first piece of information that we have, is always means equal, is about 2/3 of the length of an average blue and yellow macaw. What they're asking us here is what is that length of the blue and yellow macaw, and they tell us that the toucan is about 24 inches long. So now we're going to write this equation. We've got the length of an average toucan, which is 24 inches. And we say that that is, again, we know is means equals 2/3 the length of an average blue and yellow macaw. So that is what we're trying to find. So we're going to say x equals the length of a blue and yellow macaw. So I wrote the equation, defined the variable, wrote the equation. Now I'm going to solve it. So to solve this, I'm going to multiply both sides by the reciprocal of 2/3, which would be 3/2. And I get x equals 36. So the average length of a blue and yellow macaw is 36 inches. 36 inches would be the average length. And then step 5, does that make sense? Knowing that a toucan is about 24 inches long and knowing that the blue and yellow macaw is going to be longer than that, yes, it does make sense. Our next example comes from page 89 in our book, problem 2. It says we're using a bulletin board to advertise community service opportunities in the town. You plan to use half a sheet of construction paper for each ad. You need 5 sheets of construction paper for a title banner. You have 18 sheets of construction paper. So how many ads can you make? So first I'm going to define my variable. My variable is going to stand for what I'm looking for. How many ads can I make? So let's let x be number of ads to make. Okay, now it tells me I plan to use a half a sheet of construction paper for each ad. So that would be 1/2 times x, however many ads I can make. And I need 5 sheets of construction paper, so I'm going to add 5 more to that. And with the title banner and the paper that I need for the ads, I have a total of 18 that can be used, so that equals 18. So now I'm going to solve this equation. I'm going to solve. So I'm going to minus 5, and then I get 1/2 x equals 15. Multiply both sides by 2, and I get x equals 30. So for my answer, I can make 30 ads. Does 30 ads seem reasonable considering I'm using a half of a sheet per ad? Yes, it does. So I followed all my steps. Now let's look at our last problem here that we're going to look at. It says Martha takes her niece and nephew to a concert. She buys t-shirts and bumper stickers for them. The bumper stickers cost $1. Martha's niece wants 1 shirt and 4 bumper stickers. And her nephew wants 2 shirts but no bumper stickers. The total is $67. So what is the cost of 1 shirt? So first, what I'm looking at, what is it asking me? Cost of 1 shirt. So I'm going to let that be my variable. Let C equal cost of 1 shirt. Now I'm going to write my equation using that variable C. Martha takes her niece and nephew. Now it says the niece wants 1 shirt, which would be 1C. And she wants 4 bumper stickers, which would be 4 times $1. The nephew wants 2 shirts, which would be 2 times its cost, but no bumper stickers. And her total bill is $67, so equals 67. So I'm going to combine my like terms first when I'm solving the equation. So I have C plus 2C, which is 3C. Subtract 4. Divide by 3. And I get C equals 21. So to state my answer, the cost of one shirt is $21. Does that make sense? Yeah, it makes sense. A shirt costing $21 is definitely reasonable. So that makes sense.